Hi, I'm going to go over 13.4b for the Eulerian description of velocity. And B and C, I feel like we're a little bit harder just algebraically, and so I kind of just wanted to approach it in a couple separate videos. And so these are the given x's that we were giving in the Lagrangian description. So the first thing we're going to want to do is translate them over to the Eulerian description. And so as you can kind of see, what I've done here is what you end up needing to do is just putting this over to the other side to solve for x1, as I've done right here for x1 and x2. And since x3 isn't really dependent on anything, all it's going to happen is just switch over, so we're not going to really worry about that one. So when we move it over, we still have these Lagrangian descriptions in our on the right-hand side of our equation. So what we're going to do is use a system of equations to solve this. And so I did all of this algebra by hand, so if I made a mistake, please forgive me. But so what I ended up doing is just solving for this by plugging one into the other. And when you plug x1 into x2, you end up actually getting this. And so this is what happens when you just solve for x1 in terms of the Eulerian descriptions, and then same with x2 and x3. So these are your components. And so kind of moving on to actually finding the velocity is we're just gonna, very similar to part A, we're gonna take the derivative of the large x. And so taking the derivative of that, we end up getting this. And so I ended up using a derivative calculator to calculate this. So that is the velocity of one. The second one, same thing, taking the derivative, and you end up getting something like that. And the third one, the derivative of x3, which is 0, is 0.